Distance and displacement. Okay, here's the supplies you're going to need: ruler, scissors, highlighter, glue, and paper that you're going to cut apart. Okay, let's go and do table of contents before I forget about it. This is page 4. Okay, so turn to your table of contents. Date, that kind of depends upon which class you're in, but it should be 1/16 for most of you. Okay, at least this is the day we're starting it. You're probably going to finish it next week. Entry, distance and displacement. Okay, page 4. There will be a practice worksheet on this, but you're probably not going to do that till next week. Okay, distance and displacement. Take the paper, cut off the border, cut out every single box. You end up with 10 boxes. And the picture, just cut a box around it. And pause. Okay, with this video, with this journal entry, we are going to be doing a T-chart in the first part of this. So the easy way to do that is take the paper, okay? We're going to fold it, line up the red lines, okay? And put a crease down the middle of the page there. Doesn't need to go all the way down because T-chart's going to be just the first top of the page. And that gives me the line I'm going to use to draw right down the middle. Okay. On the left, write distance. Sorry, on the left and the right, write displacement. Okay, two very similar concepts. Okay, so we're going to do a compare and contrast to the two of them. Alright, so the first thing we have are the symbols. Okay, one's distance, one's displacement. You have no idea which ones they are. So I'm just going to get started and show you. So go ahead and take that. Grab your glue. As little glue as possible. You don't need a lot. A very little bit of my glue and it stays forever. Now, a little note about this. Emphasize it is a lowercase d for both of them. And that triangle in front, okay, that's actually a letter in the Greek alphabet. And that letter is called delta. So this is actually said delta D, okay? It could also be delta X. This is actually what they use in college, delta X. This is the state of Texas. Don't ask me why. I don't know. So, distance, displacement. You need to know the symbols for those, okay? We use those in formulas. All right. Now, distance and displacement. Like I said, very similar concepts. So let's look at the definitions here, okay? One of them is how far, or the length of the winding path traveled. And the other one is how far and in what direction, or the length of a straight line between the two points. Okay? So those definitions go like that. A distance is simply how far. Okay? How far it is from one place to another. Whereas your displacement includes direction. Okay, how far, but in what direction you're going. Now, talking about instruments. Instruments of measure. How do we measure distance or displacement? Okay, with one of them we use a meter stick, measuring tape, or odometer. With the other one it's a meter stick with a compass, a measuring tape with a compass, or an odometer with a compass. Okay, well, what is a compass? That's this thing. This thing tells us north, south, east, and west. Or in other words, it tells us the direction. Direction, displacement. So this is displacement, this is distance. Go ahead and glue those in. Okay, now my suggestion with this one, glue it in a little bit to the left so you've got enough space to put in the compass, picture of the compass on the right. Okay, now next, units of measure. Okay, units of measure. Which one's which? Well, if you look at it carefully, you realize they're exactly the same. Distance and displacement are both measured in either meters or kilometers. Okay? Most common units. Alright, so it doesn't matter. You need to know these are both the same. So you can either put them both sides like this, or you can do like what I do and put it right there in the middle, and that emphasizes that the units of measure are the same for both distance and displacement. Alright. Now, distance and displacement. We have this vocabulary words, scalar and vector. Scalar and vector are adjectives. They describe variables. So scalar variables only have magnitude, which is size. But vector variables have magnitude, which is size, and have direction. Okay, so direction, we're talking about displacement. So displacement is a vector, distance is a scalar. Okay, we'll talk about scalars and vectors off and on throughout the class. Okay, but it's good to know the difference between scalars and vectors. All right. Okay. Now, just to kind of emphasize that number one difference between distance and displacement, get your highlighter. Highlight the word displacement. And then highlight in the definition of displacement the word direction. And then highlight the picture of the compass. Okay. And then highlight in the word under vector, highlight the word direction again. Okay. Trying to emphasize that displacement has direction, distance does not. That is essentially the difference between the two of these. Okay. And one last thing. Okay, so under distance, draw a dot, right? Label A, draw another dot, label it B. Okay? This goes back to that definition of the length of a winding path traveled. From point A to point B, the path usually isn't straight. Usually kind of goes all over the place, and it doesn't really matter where it goes. If you're doing the distance, you would measure the entire length of that. And that would be your distance from A to B. Okay? It's the path. All right? The path, regardless of what shape that path is, that's distance. Okay? From A to B. Now, if you're talking about displacement, trying to get from point A to point B, it's a straight line. Straight line from A to B. Okay? Now, here's the interesting thing about vectors. Okay? Vectors can be drawn as arrows. Okay? Vectors can be drawn as arrows. So if I'm going from point A to point B, straight line, but it's going to be actually an arrow pointing at where I'm going. So that is a vector. Okay? Now, take a moment, draw a little squiggly line to separate the notes. We're going to change concepts. So this is distance and displacement, the compare and contrast. Now we need to do a little bit of review on the concept of the Pythagorean theorem. This you should have learned in geometry, probably, maybe algebra. Okay, Pythagorean theorem. So the Pythagorean theorem, hopefully what comes to mind is a squared plus b squared equals c squared. Okay? The Pythagorean theorem is about triangles. And not just any triangle, but what are called right triangles. Okay? Only works with right triangles. Well, what is a right triangle? Well, that means that one of the angles has 90 degrees. It's called a right angle, therefore it's called a right triangle. Okay? So the Pythagorean theorem only works with right triangles. A squared plus b squared equals c squared. These are referring to the sides of the triangle. Side A, side B, and side C. Okay? Now, in physics, especially in my class, the only thing we're solving for is the C. Alright? We will have A and B, we'll need to find what C is. So we need to rearrange this formula so that we're solving for C. This formula doesn't actually solve for any one variable, it solves for the C squared. Well, we want C all by itself. So algebra, we want to rearrange that formula, we want to get that squared out of there. And so you got to do the opposite. The opposite of squared is square root. What do you do to one side? Do to the other. Those two cancel out. So you end up with C is equal to the square root of A squared plus B squared. Okay? That is the formula rearranged. That's what we will end up using in this class. Okay? So that's distance and displacement. Good introduction. And we're going to go to the OOPS page for some practice. So to the OOPS page, remember, do not turn the page, it's just the page right next to it. Okay, so right there we've been doing notes. Right here beside it, okay, the back of metric measurement, you see the page there. We are going to just do a little bit of practice, review, put it into looking at examples. Okay, so right here on the left side, go ahead and write down 43M, 97.3 km east, 645 m left, 36.21 centimeters cm, 4,430 km kilometers, 78 meters, an arrow pointing up, 96 km, arrow pointing that direction. Okay, these are all measurements. Now let's classify them. Categorize them as either distance or displacement. Remember, the difference between distance and displacement is direction, direction, direction. 43 meters. No idea what direction it's going, so we already have distance. And get some practice in there, go ahead and put in the symbol D. 97.3 kilometers east. East tells us what direction it's going, so this is displacement. Which is delta D. 645 meters left. Distance or displacement? Well, we have direction, so meters, direction, displacement. .21 centimeters. All right, it's not meters or kilometers, but it's still measuring. It's still a measurement that from the same idea. This, no direction, distance. .430 kilometers, no direction provided, distance. .78 meters with an arrow up. We have the magnitude, how big it is, but that arrow is telling us what direction, so we have direction, so that's displacement. delta D. And 96 kilometers with an arrow pointing to that direction. Again, we have direction, so it's displacement. Okay. So put those little examples in there just because I need you to be able to be aware of that. If you're writing down, if you're recording a displacement, you need to include the direction. If you don't include the direction, it's just distance. All right, now below that, let's do another visual. Okay. Draw a dot over here to the left side, label it A. Okay. Go down a few lines, draw a dot, label it B. Go over to the other side of the page, down a line, draw a dot, label it C. Go down a few more lines, middle of the page, draw a dot, label it D. Go back up to where A is. Go all the way across. Over on the other side somewhere, draw a dot, label it E. Okay. Now take your ruler and connect the dots in order. So, A to B, B to C, C to D, and D to E. All right. Imagine this is the path that's being traveled by an insect. Okay? I want to know what the distance is. Distance from A to B. Alright, well, to figure that out, use your ruler. Now, from what we learned from metric measurements, which edge of the ruler are we going to use? Are we going to measure in inches? Or are we going to measure in centimeters? Metric, centimeters. Okay, so from A to B, whatever yours is, you write it down. It's obviously going to be different from mine. So I have here from the middle of dot A to the middle of dot B, 3.7 centimeters. From my B to C, 9.4 centimeters. From my C to D, so you need to measure and do yours. Practice measuring, practice using a ruler. Now, all of those measurements, add them up. To get the distance, you just got to add them up. And I get 28.6 centimeters. That's my distance. Displacement. Okay? Displacement. Go back to the definition of displacement. Alright? It's the length of a straight line between. Okay? So if I want a straight line between where I start and where I end, okay, that's going to be my displacement. Well, to emphasize, go ahead and use your highlighter to draw your displacement. And I want you to practice drawing it as an arrow. All right, vector. Displacement. Well, how long is the displacement? Measure from your point A to your point E. Mine. I've got 10.5 centimeters. Okay? Now, from what we learned up here, displacement needs to have a direction. Okay? When we're dealing with a piece of paper, we'll actually draw a compass. We say the top of the paper is north, the bottom of the paper is south, the right side of the paper is east, and the left side of the paper is west. So, north, south, east, west, just like a map, this is going to be 10.5 centimeters east. Now, it's a displacement. Okay? So you're going to see stuff like this in the quiz. All right, you need to be able to recognize measurements as distance or displacement. You need to be able to understand this concept right here. All right, distance, you add up the length of the path. Displacement, straight line from where you start to where you end. Okay, know the difference between distance and displacement. And Pythagorean theorem, that's what we're going to be using, working a lot with that on actually the worksheet and the quiz. Okay, so that is distance and displacement.